What if I told you that astronauts are literally traveling through time? Not by years, not by months, but every second they spend in space is slightly different from every second we experience on Earth. It sounds like science fiction, but it is actually a proven scientific fact. The strange part is that space does not need a magic clock. Time itself is part of the fabric of the universe. Stretch that fabric with gravity, or race through it at incredible speed, and clocks stop agreeing. Today we are exploring one of the strangest discoveries ever made. Why is time faster in space? Let's find out. Most people think time is constant. A second is a second, a minute is a minute, and an hour is an hour, no matter where you are. For centuries, scientists treated this as obvious. Then, in the early 1900s, a physicist named Albert Einstein changed everything. Einstein discovered that time is not fixed. Time can speed up, time can slow down, and surprisingly, gravity plays a huge role. Before Einstein, space and time were often imagined as a silent stage where the universe performed. Einstein's idea was much stranger. Space and time are part of the performance. They can bend, stretch, and change, depending on where you are and how you move. Scientists call this effect time dilation. Imagine standing at sea level. Now imagine your friend standing on top of a very tall mountain. Both of you have perfectly accurate clocks. Who ages faster? Believe it or not, the person on the mountain does. The reason is gravity. Gravity does not just pull objects together, it also affects time itself. The stronger the gravity, the slower time moves. The weaker the gravity, the faster time moves. Near Earth's surface, gravity is stronger. Higher above Earth, gravity becomes weaker. That means time moves slightly faster at higher elevations. The difference is tiny. You would never feel it during a vacation in the mountains. But modern atomic clocks are so precise that they can measure it. Raise one clock higher than another, and after enough time, the higher clock gains a little bit of time. The results match Einstein's predictions with astonishing accuracy. Now let's travel into space. As you move farther away from Earth, gravity becomes weaker. And according to Einstein's theory, weaker gravity means faster time. That means a clock floating high above Earth can tick slightly faster than a clock sitting on the ground. If you could compare them side by side for long enough, you would eventually notice the difference. It is small, but it is real. And it is happening right now. Every satellite orbiting Earth experiences this effect. Space is not just far away, it is a place where time has a slightly different rhythm. Just when things start making sense, the universe adds another twist. Speed also affects time. According to Einstein, the faster you move, the slower time passes for you. Imagine two identical twins. One stays on Earth, the other boards a spaceship traveling at incredible speed. When the astronaut returns home, less time has passed for them. The Earth twin would be older. Scientists call this idea the twin paradox. It sounds impossible, yet experiments have repeatedly confirmed that moving clocks run slower than stationary clocks. We have seen this in precise aircraft experiments, in particle accelerators, and in the behavior of fast-moving particles from space. So time dilation has two major ingredients: gravity and speed. One can make a clock tick faster, the other can make it tick slower. Astronauts orbiting Earth experience both effects at the same time. They are far enough away from Earth that gravity is weaker. That causes time to move faster, but they are also traveling around Earth at thousands of miles per hour. That causes time to move slower. These two effects compete with each other. For astronauts aboard the International Space Station, the speed effect is slightly stronger. As a result, astronauts age just a tiny bit slower than people on Earth. Not enough to notice when they come home. Not enough for dramatic movie aging, but enough to measure. This is one of the beautiful parts of relativity. The same theory explains mountains, satellites, astronauts, and black holes with one connected idea. You might think this is just a weird science fact, but it is actually important to everyday life. Every time you use GPS, Einstein's theory is helping you. GPS satellites orbit high above Earth. Because gravity is weaker there, their clocks run faster. But because they are moving quickly, their clocks also run slower. Engineers correct for both effects. The gravitational effect is larger for GPS satellites, so their clocks would drift ahead overall if we ignored relativity. That drift may sound tiny, but GPS depends on timing with extreme precision. A timing error of just a few billionths of a second can become a location error on the ground. Without these corrections, GPS systems would quickly become inaccurate. Your maps would be wrong, your navigation would fail, and your phone would not know where you are. Now let's visit one of the strangest objects in the universe. A black hole. Black holes contain enormous amounts of mass packed into a tiny area. Their gravity is incredibly powerful. Near a black hole, time slows dramatically. Imagine spending 1 hour near a black hole. Meanwhile, years might pass for someone far away. In extreme situations, entire decades could pass elsewhere while only a short amount of time passes for you. The stronger the gravity becomes, the slower time moves. Black holes push this idea to the absolute limit. Near the edge, light struggles to escape. Clocks appear to crawl from the perspective of someone far away. It is not an illusion caused by broken clocks. It is the geometry of space-time itself becoming extreme. So why is time faster in space? Because gravity becomes weaker the farther you travel from Earth. And weaker gravity allows time to move faster. But speed can also slow time down. The universe is constantly balancing these strange effects. The result is something truly incredible. Time is not the same everywhere. Every planet, every star, every galaxy experiences time a little differently. And right now, somewhere in the universe, time is moving at a different rate than it is for you. Thanks for watching. If you enjoyed this video, be sure to like, subscribe, and join us for more amazing science mysteries. See you in the next video.